talk about the costs of first reproduction episode into long-lived seabird species, the Scopoli shearwater, and the European storm petrel with the use of long mark-recapture data. Many seabirds restrict reproduction to a very specific period of time, usually around spring or summer when the weather conditions start to favor reproduction. But nevertheless, the first reproduction episode can carry some costs related to it, and those costs are felt through a demographic effect, usually low survival estimates or reduced future breeding propensity. In long-lived open populations, there are two characteristics that might appear. The first one operates at the population level, and it's the acknowledgement of the presence of high intrinsic quality breeders and low intrinsic quality breeders. Low intrinsic quality breeders have less survival probabilities, and thus makes that when looking at a bigger scale, at a bigger picture, the first reproduction episode seems particularly costly. The second one, at an individual level, seabirds are capable of deferring the reproduction attempt, and thus they can avoid the potential negative consequences that reproduction might carry for them. What we are interested in finding out here is if there are sex-biased differences. Usually in many seabird species that are polygamous, those sex-biased differences in the costs associated to first reproduction can appear usually if there are, for example, male-male competition processes. But in many seabirds that are monogamous, such as the ones studied here, and they show biparental care, meaning that they share the costs of chick rearing and incubation, those costs can also appear. And those, when in the case of being female biased, those have been related with the energetic challenge that means for females and not for males to construct the egg. What we are attempting here is that by estimating the transience probability, and that is the probability of a newly marked individual to disappear from the population beyond to what is expected, we want to use it as a proxy to evaluate the costs of first reproduction. So whenever we go sampling, and it's not the first sampling occasion, we will be acknowledging the existence of three types of individuals: resident not marked, resident marked in previous occasions, but also transient individuals. Those individuals are going to be captured once, but never recaptured again during the study duration. This was done with two Procellariiformes species, as I said, the Scopoli shearwater, Calonectaris diomedea, and the European storm petrel, Hydrobates pelagicus. Both of them are species found to be breeding in the Mediterranean. Both of them are long-lived species known to delay their breeding attempt, and they have high return rates to their breeding colonies. In the case of the Scopoli shearwater, they perform a migration reaching the waters of the southern hemisphere, and thus they are exposed to the climatic conditions on the area. Those are summarized by the large-scale climatic index, the Southern Oscillation Index, which we expected to affect their survival, but also their transience probability along with sex. We expect females to show larger values of transience probability due to the costs of egg formation. In the case of European storm petrel, the situation is a little bit different. Their wintering areas were not known. Those have been inferred, and they found to be dispersing over the Mediterranean basis during winter. Thus, they are exposed to different climatic conditions, which are summarized by the North Atlantic Oscillation Index, in which we expected to affect their survival. And sex is going to play a role with the transience probability. Again, we expect females to show larger values. Through continuous visits at study colonies, Pantaleu Islet for Scopoli shearwater in Mallorca, and Benidorm Islet for European storm petrels, and the ringing of each individual found to be breeding in the area with the use of unique alphanumeric codes, and also sexing those individuals. As you can see in the case of the Scopoli shearwater, biometric measurements were used, and also vocalizations with females having harsher vocalization than males, and in the case of the European storm petrel, genetic sexing was used for the species. Doing all this process, you obtain the final capture histories. In my case, the final database for the Scopoli shearwater was composed by 886 individuals. breeding in Pantelleria Islet from 2000 to 2019, and 459 individuals of European storm petrel breeding in Benidorm Islet from 2005 to 2019. When working with capture mark-recapture data, it is necessary to do a preliminary assessment of the data. This is done by fitting the data to a fixed variable model. In our case, we chose the Cormac-Joly seabird, which is a time-dependent model, and this process was done in the software UCare. The Cormac-Joly seabird model relies on 4 assumptions. The first one is that all marked individuals have the same survival probabilities from one time occasion to the following one. All individuals have the same detection probability. All marks are neither lost or overlooked, and all sampling occasions take place within the same time interval, and release is right after first capture. Nevertheless, in open populations, there are 2 assumptions which can be violated. The first one, it's tested under the test component 3.SR, and it detects the presence of transients. The second one is detected under the test component 2.CT, and it detects the trap dependence or the heterogeneity on capture. If departures from the main assumptions are detected, those need to be incorporated in the model formulation. As you can see, the multi-event modeling framework works based on the definition of 3 parameters: the initial states, transition probabilities, and events. The initial states, we have animal aware of the trap, animal unaware of the trap, and dead. Those last 2 states are in gray because they are not practically possible, but this is a way to include the detection probability in the model formulation. The transience probability was included as a transition probability, as you can see, which is modeled in a 3-step approach. The first one being transience probability, survival probability, the second one, and detection probability, the last one. In the last column, we have the events considered, which are 0 when the individual is not captured, and 1 when the individual is captured and breeding. The models were fitted using the software eSearch. For the results, as you can see, the goodness of fit is significant for females of both species for the transience effect, and the heterogeneity on capture is significant on both genders for both species, meaning that those parameters were included in the model formulation, and the remaining over dispersion was accounted in a variance inflation factor, which you have the values we obtained down below the table. The final models obtained for Scopoli shearwater are presented in a table format, as you can see. What we have to look is at the IMBRSea values, because those are the main information criteria we've used to position, to rank the models. As you can see, the first model retains sex as a good predictor for transience probability, whereas survival depends on the additive effect of sex and time. As you can see, females show larger values of transience probability, and the survival of those remaining in the colony, it is also higher for females. We also plotted this graph in order to know how the transience probability evolved over time. And as you can see, as you might know, the values for transience probability are very close to 0 in some sampling occasions, whereas they are much larger in other ones. As you can see, the confidence intervals, they are also quite large, and this is likely due to the low number of newly marked individuals in some sampling occasions. The larger scale climatic index was also plotted in the inner graph. As you can see, it's the red line in the graph. The models obtained for European storm petrel also retain sex as a good descriptor, as a good predictor for transience probability, and females also show higher values of transience probability, whereas survival remains rather constant. In the case of the Scopoli shearwater, though, if we look at the last column of the delta AIC, which are the values compared to the best ranked models, the values of AIC compared to the best ranked model, we can see that the difference between the values is minimal, and thus we cannot say that the best ranked model is the best model describing the population for European storm petrel. And that is the reason why in my thesis, in my work, the discussion, the results were not further discussed in the case of European storm petrel. To start the discussion with, we can say that we found that sex has an influence on the costs of first reproduction. Those expenses are related to a process that females undergo, but not males, and this process is the formation of the egg. Those costs have been seen to be also constant and sustained over time, and they have been suggested that those could also respond to selection. Coupled with the fact that low survival adult estimates have been found over time in different studies in Pantaleo Islet, and Pantaleo Islet has also been suggested to act as a sink colony, only rescued through immigration processes. And also, even if it was not the scope of this work, there's a male-biased known bycatch through longline fisheries in the northwestern Mediterranean, and thus we can say in conclusion that a part of the female population of Pantaleo colony is likely to die as a cost of first reproduction during the breeding season. The results for European storm petrel, as I've already commented, there's a lack of power, likely to the lack of data also to produce robust estimates, and thus led us to obtain closely ranked models. So at the end, we can say that we failed to detect biologically meaningful effects or at least strong effects for the species. As a general conclusion, final remarks, we can say that these higher survival costs associated to first reproduction for females breeding in Pantaleo are a result of the costs associated also to egg production and laying. And thus we can say, as it has been suggested in other studies, that different selective pressures might be acting on males and females of Scopoli's shearwater. Our climatic indexes included as covariates didn't show a clear, significant effect on the models proposed for the species. We talked about the lack of power in the European storm petrel models, but there is also a slight lack of power in the models obtained for Scopoli shearwater, so the results need to be treated with caution. And this lack of power poses the need to continue sampling in order to better understand how the costs of reproduction act over large timescales. Those are the references that I have used. I want to thank my supervisor, my family, and everyone. Thank you very much.